Hello everybody, it's Mr. Birdie. I'm in my backyard right now. Right here is where I plan on putting a garden as soon as the rain stops and it dries up a little bit. But I do have one issue. It's pretty wet. In my backyard I have a creek. Probably can't really see, but there's a couple trees that are falling over, and so this little laneway back here is starting to flood a little bit. But what I want to do today is test the pH of that pond water, or that creek water. And hopefully I'm going to do that with some household items because I don't have any way to test pH at my house. I don't have a pool, so there's no reason for me to buy pH strips. So let's see what we can find around my house, and hopefully we can get that pH tested. Okay, so in order to test the pH of the creek water in my backyard, I'm going to be using a pH indicator. And pH indicators, to explain it simply, are just a chemical that has a certain color, and based on the pH of the solution that it's placed in, it'll change that color. So something that's convenient is that things like plants and flowers, they have what's called anthocyanin, and anthocyanin will change its color from red to purple to blue based on the pH of the solution that is placed in. Alright, so there's a few different structures of anthocyanins that you can find online. This is just one of the simpler ones that I could find. Basically, this is the structure of anthocyanin when it's in an acidic solution. And remember, when you're going from acidic to basic, your hydroxide ion concentration is increasing. And so in an acidic solution, our anthocyanin appears red. As we get to a more basic solution, it's going to appear violet. And you can see the difference between the red and the violet is that you are adding a hydroxyl group to that ring of carbons. And so here we're going from 1 OH or hydroxide group to 2. Now in the most basic conditions, it's going to appear blue and sometimes even yellow based on the anthocyanin, the specific anthocyanin. And so here we're going to an even more basic environment, so now we're adding even more hydroxide groups around that carbon ring. Okay, so while I don't have any flowers really around my house, I do have, well, I guess besides this guy, but I'm not taking any leaves off of that. I do have some purple cabbage, which does contain anthocyanin. So I'm going to be blending up some of that, and we're going to make our pH indicator using this. Okay, so quick correction. It's actually called red cabbage. I know I said purple cabbage. It's just the color purple, but it's actually called red cabbage. So what I'm going to do is I'm going to heat up some of this water in the microwave, and then I'll take a couple of the leaves of cabbage, and we're going to blend them up. Alright, so I got my hot water. I'm just going to take a couple of these leaves of cabbage, put them in the hot water, and then we'll start blending them up here. Alright, so I've only blended up just a little bit, and you can already see that the solution's starting to turn a little blue. Just blend this up a little bit more to get some of those big chunks out of there. Alright, so we have our anthocyanin chilling in the solution here, but there are still some chunks of cabbage, and so I'm going to put this through a coffee filter just to see if I can get some of those chunks out. Okay, so I got my coffee mug, I got my coffee filter. I didn't even know I owned rubber bands, but I put some rubber bands around the coffee filter just to get it to hold still. And so I'm going to take our blended up cabbage and hot water here, and I'm just going to pour it through the filter, and hopefully we can filter out those chunks of residual cabbage. Alright, so while my cabbage indicator continues to filter through the coffee filter, I'm just going to tell you what my plan is. So I'm going to get some ammonia, I've got some vinegar, I'll probably find some baking soda, some lemon juice, and I'm just going to pour each of those into a clear plastic container. I'll add some of the indicator to it, see what color it changes, and then I'll go in the backyard, grab some of the creek water, and then pour that in its own container. I'll pour some indicator in there, and then hopefully I have a wide enough range of solutions that have a wide enough range of pH, and so we can compare the color of the creek water to the color of one of the other solutions, and we can see what the pH is. Okay, just for reference, ammonia has a pH of about 11.6. Vinegar's pH is typically around 2.2. I'll grab some tap water that usually has a pH, it should have a pH of 7. And then if I make a baking soda solution, that should have a pH of about 9. So from there we should have a nice wide range and we'll be able to see what the pH of that creek water is. Okay, so I'm in my backyard, I'm about to go get some creek water. My neighbor decided it was a great time to cut the grass in the rain. He probably sees me out here with my cup, and hopefully he doesn't think I'm insane. Alright, let's get some of this water. Okay, we got some of the creek water. I only got a little bit of dirt in there, but let's go test it out. Okay, filtration is still going strong. I only got a little bit left, but this stuff stinks pretty bad. Okay, so it turns out I don't have any baking soda, so I'm going to walk over to my brother's house and see if he's got any for me. Alright, I got my baking soda. We are good to go. Okay, so my cabbage is done filtering. That's definitely going to stain that mug blue forever. My god, that smells so bad. Okay, so what I got here is I have ammonia, and in parentheses I just have the pH of the solution. So ammonia has a pH of 11.6. I got my baking soda solution. It says a pH of about 9. I got tap water, pH of 7. And I have vinegar, pH of 2. So I'm just going to take a little bit of my indicator here, put it in each one of these solutions, and then we'll see what color turns. And then finally, we will test the unknown. Alright, so first we're going to test the vinegar. So I'm going to take a spoonful of my cabbage indicator. We're just going to pour it right in here. And you can see, because vinegar is acidic, it turns this nice pinkish reddish color. Okay, moving on to the tap water. Again, we'll take a little spoonful, put it in the tap water. Here it's you can see it's slightly blue. I'll add a little bit more. Probably should have used a different spoon for each one because now I'm contaminating it, but this is just some backyard science, so I'm not too worried. Alright, so that's a little blue. Okay, next is the baking soda. Take a little bit of this, put it into the baking soda. You can see it turns a much darker blue color. A little bit more. Let's stir it around. So you can see going from, so far we got a nice gradient going here. Going from a pinkish red with a pH of 2.2, tap water, pH of 7. It's kind of like in between, it's like a purplish color. Now we're going into the basic side. You can see our baking soda is very much blue. Alright, lastly is the ammonia. So I'll take a couple spoonfuls here. Put it into the ammonia. Alright, you can see we're at the end of our spectrum here. So once you get past this blue color with anthocyanins, you actually get into this yellowish greenish color, which is pretty cool. So you can see that this is very basic. Alright, now for the moment of truth. We're going to test our unknown. I'm going to take some of our trusty indicator. We're going to pour some into here. Oh my god, this smells terrible. Alright, I'm actually pretty surprised. So this is turned blue, so it's pretty basic. I mean, it's a little bit darker because of the dirt that was in there, but it is on the basic side. So here's our final gradient. We have the vinegar, we have the tap water, the baking soda, the ammonia, and then lastly, our unknown, the creek water. Okay, so hopefully you guys enjoyed that video. It was just a fun little experiment that I wanted to try. Actually, in the middle of making this video, I found out that school was going to be closed for the remainder of the year. So I know it sucks that we don't get to finish out the rest of the year, but hopefully this video shows you that just because we're not in school anymore doesn't mean you can't keep learning stuff. So try to learn something new every day. I love you guys. Take care. Alright, so my cabbage is done filtering. That is definitely going to stain that mug blue forever. And